this up. Or I'm sorry, example 2, that's what I've written on here. This is following a +2 pattern. And example 2 in your notes from yesterday followed a +3 pattern. Okay? So if I wanted to model this formula based off of this one, well, first of all, where do you think this 3 came from? The +3. So if this one's a +2, what do you think your formula is going to start off with? 2. Good. So your formula, A of n equals 2. What do you think is going to come next?
N.
Just 2 plus 1? N. So 2 times whatever the term number is, and then +1. So let's see if that actually works out. If I start with the first term, 2 times n, well, that'd be 1. So what's 2 times 1?
2.
Then 2 plus 1?
3.
So did it work?
Yes.
Okay, let's try the next one. 2 times what? 2, which is
4.
plus 1?
5.
Did it work?
Yes.
All right, we're on a roll. Let's try one more. 2 times 3 is
6.
plus 1?
7.
So it works, right?
Yes.
Awesome. So now let's say I wanted to use this formula to find the 15th term. So to Jackson. What I want you to do in your calculator is I want you to start at 3. Okay, that's the first number. And then I want you to do +2 14 times after that, and then don't tell me what your answer is. Okay? Here, why don't you use this one so you can actually see how many 2's you put in there. Okay, 14 times. Okay, so for us, we're going to actually do the formula. So A of 15, that means my 15th term, equals 2 times what? N, and what's N this time? 15. 15 plus 1. Well, what is 2 times 15? 30. And what's 30 plus 1? 31. So the 15th term should be 31. Is that what you got, Jackson?
Oh,
Yeah?
yeah.
So in the calculator, Jackson did started at 3, because that's the first number, right? And he did +2, +2, +2, +2, +2, +2, +2, 14 times. Well, that's going to take forever if I were to ask you to do the 200th term, right? So that's why we can use our formula. Any questions about A or B on that one?
No.
Sweet. Okay. Now what I want you to do is I'd like you to please, we're going to graph this. So let's do, our numbers are kind of small, so we can spread out 0, 1, 2, 3, 4, 5, and then going up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a little squishy. And remember, this is n on your x, and then this side is the term, like the pattern. So go ahead and plot those points, please. And if you're a little confused, you can ask your, you can let your table for a little bit of help. If you already graphed it yesterday and our scales are slightly off, like I'm totally fine with it as long as it's the same. This is X, and I wrote the scale on the screen.
Can you plug over to
All right, let's compare graphs. Are we the same?
Yeah.
Yeah. Hey, what kind of function did that make?
Linear.
Linear. Can someone raise their hand and tell me how you know it's linear? What's a big deciding factor? Asia? It's a straight line. Good. All right, let's move on to number 2, unless there's any questions.
Nope.
Okay, number 2. This sequence follows a times 4 pattern. So let's make our table. N is your careful. Oh, yes, you're right, half. Okay, what's the second term?
4.
I thought that was the first term. What's the third?
16.
The fourth?
64.
Good. Okay, so this one follows example 1. So if you want to look at example 1 in your notes, I'm going to need to zoom out a little bit. Switch over. Okay, so modeling off of example 1, this one was following a times 2 pattern, right? In between each term here, I was multiplying by 2. And the formula for that one was a base of 2 to the n minus 1 power. So how do you feel about this one? What's your base going to be for this guy? 4 this time. Good. So a of n equals 4 to the n minus 1 power. Okay. So I want to try this out and let's see if it actually works. And since we're dealing with exponents, I'm going to actually do this on my whiteboard so you can see it a little bit better. Okay. So we have here's our table, 4 to the n minus 1 power. So if my first term is 1, so 4 to the 1 minus 1 power, which would be 4 to what power?
0.
And 4 to the 0 power is?
1.
Thank you for not saying 1 or 4. I feel like I always hear 4 or 0. No, you're so close. It's 1. Okay, let's try the next one. 4 to the 2 minus 1 power would be 4 to what power?
1.
And that would be?
4.
Is that what we want?
Yes.
Yeah. All right, let's try the next one. So 4 to the 3 minus 1 power would be 4 to what?
7.
And that would be?
16.
Good, and that's what we wanted, right?
Yes.
So, and will the next one give me 64?
Yes.
Absolutely. Okay. Absolutely. All right. So now that we've checked it, we know that our formula is good to go. I want us to oh wait, we have to find the 15th term. Duh. Okay. Jackson, you want to do it again?
What?
You want to
Yes,
figure it
you.
out on the calculator for me? So this time you're going to start at 1, and you're going to multiply by 4 14 times. All right, so now we're going to find the 15th term. So A to the 15, or A of 15 equals 4 to the 15 minus 1 power. So that's 4 to the 14th power, and you guys might need to use your calculator to figure out what 4 to the 14th power is. Yeah. You might have accidentally put double multiplication somewhere. So you guys with your calculators, you're going to do 4 to the 14th power. Do you remember how to do that in your calculators? I'm going to show you.
I need a different way.
Yours doesn't have a carrot.
What? I got 1224.
Oh, it's way higher than that, friend.
You got it. I'm smart. I'm smart.
Carrot button.
I think
Do you have a carrot button?
I got one.
4.
I got this number. That's a few months number.
Remember, it's 15 minus 1.
Oh. Oh.
Whoa, that's a big number.
Okay, if you have the Gray calculator,
Oh, that's me.
if you have the Gray calculator, what you're going to do is you're going to type in 4, and then you're going to hit this Y to the X button that's under the off button. You click that, and we're doing 15 minus 1, which is what?
14.
14. And I'm not going to hit enter because I don't want to spoil it.
You got it.
Big numbers.
Yeah.
Do you need me to show you on the blue one?
Yeah.
I got it. Can I take a
Alright, you're getting some sort of crazy number, yeah?
Yeah.
You should have got 268,435,456.
That's a
Woo! Keep in mind, you're multiplying by 4, right? I'm not just adding 4, I'm multiplying, so your number gets bigger, bigger, and bigger. Alright, let's graph this. So for our graph, we're gonna do 0, 1, 2, 3, 4. And then on your y, I'm gonna go by tens. So 10, and then I skip a line, 20, 25 if you want. Oh, that should be 30. Look, you're talking to me, you gotta count it all. 40.
Yeah.
I counted by tens. If you count by fours, I'm fine with that too. Okay, once you have your scales drawn, go ahead and graph.
Yeah.
Okay, and as you're finishing that, I'm gonna pass out your notes for today.
Oh, I didn't mind way too much.
Very hard.
That's what I'm gonna ask you. Look all the way in the back of your graph. Alright, let's compare graphs. Did yours look something like this?
Yeah. Okay.
Yeah. Hey, which function is that, Jackson?
Wait, what?
Which function was this?
Let me go to the beginning.
What kind of line was it?
Oh, exponential graph.
Exponential graph. He looked at it. Okay, so if you remember at the beginning of the year, we looked at linear, exponential, and quadratic functions. And then on this paper, we have linear and exponential. What's the name of this unit called?
Unit.
If you don't remember, you could look back at your divider or your table of contents.
Unit and function.
Integer sequences was the lesson we did yesterday.